Hello everyone. Today I want to show you how you can monitor the performance of your graph and improve your graph to be much faster to run and to use less memory. So let's start. I prepared some examples to show you how you can monitor the performance of your graph and what are the most important things that you should consider in order to make everything run faster and smoother. So let's start by looking at this simple example where I have a landscape data surface sampler, then I'm adding some random scale and rotation to my elements and spawning a list of meshes, which is currently just two different type of bushes into my level. So let's see here how you can monitor the performance of this graph. So as you can see, I have opened this profiling window, and if you don't see it, click on the window menu of your PCG graph details window and click here onto the profiling checkbox, and it should open this profiling window. And in order to see something here, into this debug object section, you must select the actual graph in your level. So here, if I cut this graph from the level, you'll see if you don't use this graph anywhere, you'll have nothing in the list. But if I paste it here, you'll have every single instance of your graph in your level. If I copy it, so I have two, now I can monitor separately the performance of each of them. And it will change based, for example, of where it is placed or what size it is and so on. So let's see this example graph. So a common thing that you might encounter is you want to make this graph a little bit more interesting. So instead of just spawning these meshes, you want to add some more details into your PCG graph. So you copy this entire section into another one and just change the meshes that you spawn. So this is a different parameter, and I'll spawn 10 different type of quarter meshes which are used here. And you just create some logic to place the new objects in your scene. So let's connect this logic. It doesn't really matter currently what the logic is, so just focus on the profiling. So I'll make the graph much more denser because I'm now spawning more objects. And as you can probably tell already, this bottom part is spawning these sticks and rocks on the ground in order to have a little bit more details created by this procedural graph. So in order to see the performance, let's click here onto the debug object, and you see that in the profiling tab, you start to see a lot of numbers, and you can look at all of them, and of course all of them are important. But here at the top, you have a summary which you can use until you need to start looking with more depth into your different parts of the graph. So into this summary view, if I click the forced regenerate, because sometimes actually most of the time until you regenerate the whole graph, your graph is caching some of the result of your objects which don't need to be recreated every time. And this is why these numbers here may not represent the full data and time that your graph requires. So clicking the force regenerate, and even better, holding the control key and then clicking force regenerate will also perform a flush cache, and it will generate everything from your graph, and you can see now the total result of the execution of your graph. So if I just click regenerate, you'll see that some of the nodes are with this gray color, and this means that the result of them is cached, so they are not rerun again, and I'm only running these white nodes at the top. But if I hold the control key and click on the top, I'm regenerating everything, and I can see the resulting time. So to generate this object in my scene, it took 34 milliseconds. And this is the time for the execution, but the actual time, because some of the nodes need to wait for some other result to be done. So this is what this total wait time means, that it's including the wait time between different nodes, and for the whole graph it took totally 76 milliseconds to run, and it used 7.6 megabytes of data. It generated rather 7.6 megabytes of data. So how we can improve this? Because I run my initial graph with these objects, I created them with collision, so I cannot walk past. Okay, so let's reduce this window a bit in order to be better seen when I'm sharing this graph. So in order to not pass through these bushes, I added collision to them, and the collision is very expensive to add to your scene with these PCG generators, which generate hundreds or thousands of objects sometimes. And to register each object's collision into the level, and then to calculate the collision for each object when your character goes next to them, is really expensive. And you can see how much by using this profiling window. So if I force regenerate everything, you saw it takes 32 milliseconds, or even better, this number, 75 milliseconds of total wait time. But if I select this second static mesh spawner, if I search for collision and disable my collision, so I'll use no collision for this, because this collision doesn't really add to my gameplay anything. I don't need collision for these small objects, just as a detail on the ground. So right now, if I force regenerate, it only takes 6 milliseconds to run this entire graph, including the collision of my original objects, but no collision on these clutter meshes, and only 18 seconds of total wait time. And the data is again 7.6, because most of the data will be the actual point locations and their properties. So you saw how changing just a single option made this graph to run much faster, around 5 times faster. And it can be even more beneficial if you are running this on top of a bigger area or generating more objects in this area. So make sure that you check your profiling window often, and you can see what improvements you can make to your graph. And an example that I can show you is here, where we are placing these objects. Let's say we were testing something and we created some transform points right here. So we want to see what will happen if we, for example, copy these points and scale them a bit or something like this. Let's say I'll connect this here, and I'll do, let's say, a smaller version, 0.25 to 0.5 for each of them, and I'll move them like 50 units random in X and Y direction. So each of my bushes have a smaller bush next to it, so it looks a little bit more detailed and adds a little bit of variation. But I decided that it doesn't really look realistic to have just a scale version of itself. I'll need another smaller bush with earlier into the development, so entirely different model in order to create this perception that I want. So I decided that I don't want this, and I just disable these transform points for now. But let's see what happens right now if I force regenerate the graph. So as you can see, it still regenerates in roughly the same time, but now the total data size is bigger, so 7.68, and if I delete this, it's 7.63. So having additional nodes, even if they are disabled, if they are connected to some active part of the graph, will actually make your data size a little bit bigger. So this is another consideration. Make sure you consider which nodes are you using and how are you using them, and clean up your graph, and you're sure that everything that you want in the graph stays there, but everything that you don't want is not cluttering your graph. So now let's look at the other example that I prepared. So this other graph, and into this other graph I want to show you something a little bit different, how to think and what to optimize in your graph. So for example, if I run this graph right now, you'll see it takes just 4 milliseconds to run, which is great, and takes less than a megabyte to run, which is also great. But if I run it on a bigger area, of course, it will use much more resources. So I need to make sure that in this small area example where I can still manage to run it without slowing down my computer, I do every optimization that I can in this moment. And what I did here is, let's disable this part and enable this thing. So let's run it right now. So the original graph was something like this. So I create this points grid, I copy the points a couple of times and move them a bit in order to create this much denser area. So if you just want a grid, you can use the create points grid, but I wanted not just a grid, but actually lines. So by controlling right now this Y axis cell size, I can control the lines distance. For example, it was originally 350, I can reduce it to 100, so it's really stacked right now, but I can go 400, so I have bigger area between the lines. But I'm using 4 copies of these points in order to fill the gaps between the grid. So if I disable these 3 copies, the original grid is like this. So I want to have lines, not just a grid. That's why I copy it 4 times. I merge everything and then project it onto my landscape. And after this, because I don't want here, for example, where the landscape is curved, I don't want this objects to follow the direction of my terrain. I want them to point up. So that's why I'll set the rotation and then rotation pitch value to 0. So I'm setting the rotation.pitch value to 0. And this way, all of my objects are now facing up. They are not following the terrain like they were before. So if I disable this node, you can see they are following the terrain. If I enable it, they are pointing up. Okay, so this is the basic logic that I created, and this graph runs fast, but it's 9 milliseconds. And if I disable this static mesh spawner, enable this one, and enable this bottom part of the graph, you'll see that now it runs in 3 milliseconds, which is 3 times faster. And what did I change? So instead of spawning my meshes with their collision, so let's play this game, and if I run next to the bushes, you'll see I have collision and I cannot go through them. So it works as I wanted, great. But what if, because I have these bushes in a line, I just create some cubes, which is what I'm doing here, and use the collision of these cubes. So I have this static mesh spawner spawning a cube with collision preset of block all. So I'll have 1 cube for each 4 of these objects, because I'm using the original grid without these 4 copies and spawning a cube with collision for each of them, and I'm scaling the cube a bit in order for this cube not to be taking too much space. But let's connect these points to a debug node, and let's change some values here in order to make this collision a bit better. So let's unlock this and do it 0.25, 0.25, 0.2 even. So something like this. So I spawn a cube and let's change the debug mesh to this cube wireframe mesh. Like this. Okay, so now it's a little bit better. So this cube is too big into the X direction, so let's reduce the size into the X direction to 1 and move it a little bit back, so -100. So what I'm doing here is spawning one cube for each of these 4 objects, and I'm using the collision of the cube in order to not spawn 4 times more collision for each of these meshes, 4 times the objects that have collision. And this will do the same for me. So let's just change that. Static mesh spawner is using the visibility set to false. So search for visible, remove these checkboxes, hidden in game, check the hidden in game for the cube, and this will make sure that this cube is not visible in your level, but it actually spawns the collision. And now you don't need this static mesh spawner with collision set to block all for your bushes. I can use the same static mesh spawner, but with collision set to no collision, which I have this one at the bottom right here. Let's enable it. And right now, let's force regenerate and select our graph. You can see that we went from 9 milliseconds to 3 milliseconds. And we are using 0.8 of a megabyte still. So when now we look at our graph and we think, can we optimize it a little bit further? So this setup right here, that I'm setting my rotation pitch angle to 0, I can get rid of this node entirely and connect this one. And now, as you remember, my bushes will follow the angle of the terrain. But into my get landscape data, I can check the get heights only checkbox. And this will not get the rotation from my landscape, it will only get the position of each point. And this will save me a node that will rotate my objects. They will be by default rotated to face up. And also you can uncheck this project rotations, but right now we are getting no rotation data from our landscape, so it will work fine. And here, let's look at this part. So we are creating 4 different copies of this points grid and moving them a bit and randomizing the rotation. But why do we merge them? We don't do any operation after this that requires everything to be just a single set. So we don't need this merge points node actually. Let's delete it and let's connect everything to this projection node instead directly. So let's force regenerate now, and you see that we are still executing our graph in 3 milliseconds, but instead of using 800 kilobytes or 0.8 of a megabyte, we are now using 0.6 of a megabyte. So we saved about 25%, let's say, of our graph usage. And it will not be much for this graph, which is just a single megabyte. But if you have a denser grid, for example, if I have here 100 units as a space between the points, and if I have a bigger grid, for example, 6,000 in size, so it's a bigger area covered by these bushes. So if I regenerate right now, it went to 8 megabytes and 33 milliseconds. Without our changes, it will be 100 milliseconds and about 12 megabytes or something like this. So you will see that the different values will grow exponentially with the amount of points that you have. So it's better to save on every level, and this way you will be sure that you made the most optimal graph, and you can take the decision for each node of your graph, which node to use, which node not to use, and you will know why it's better to use one or the other to save some data or to save some execution time. So guys, if you like this tutorial, please like and subscribe for the channel. If you want to watch these videos earlier than anybody else, you can join it into the higher levels. You'll get access to the videos earlier. You'll get your questions answered earlier. And I'll see you in the next tutorial. Bye.